Hello and welcome back to another episode of Getting into Good Oxide. Hello, Sydney.
Hey, Sebastian.
And we're back where we ended yesterday, even though part of that episode was cut off. But that's probably all right. Here we are with, before we move on to greener pastures, maybe there's some opportunities here to improve or refactor. I was looking at this duplication, but then I realized, oh wow, it's sufficiently similar or different. The only difference here is the error, really. And yeah, should this be factored out or not? And here the type is different. Yeah, I think.
To me, this is kind of part of still the config stuff, which still might change at some point, right? I don't know.
Yeah, all right.
How much sense it makes to try to predict what's going to happen there.
Yeah, very good point, actually. Then, yeah, let's leave it. My intuition, even without that note, would have also been to just keep it because it's not too terrible. It's lots of boilerplate here just for this one call that you finally make to the important one. But yeah, that's how it is. That's how all these layers are on top of each other to just get rid of a few parameters. And we started out as needing this prefix that needs actually 2 parameters to work, to needing nothing except for an object that is an object ID.
Exactly.
So, or an ID as it's now called. It's just a Git ID. So, cool. Then maybe let's check the test as well, because I wasn't entirely sure if that was already what it should be. Let's see where that is called. Twice here and there. And once we change the repo. Here could be something. Like, even though the git config changes, like having to recreate the repo and then attaching and detaching and reattaching seems like very complicated for what should be something like repo refresh config or config refresh. And this can be, like, how hard would this be to implement, I wonder? And what would it mean to do that? Is this easy to do? I mean, that would be an opportunity for me, and it's kind of a bit off topic. It doesn't have to be done. It's more like, if it's simple, could be something to look into. But besides
I'm just
that,
thinking again, like if you were to modify in future the config programmatically, would this refresh happen automatically? Like, is there ever a reason that you would have to call refresh config like in this way, or would this be kind of embedded into the config API anyway?
Yeah, I think it can't be embedded, because if something is missing, like with object databases, you know when to refresh potentially, because if an object isn't there, then you want to look for it. Then you might refresh your data structures. So that's clear because it's append only, but a config file is not at all append only. And many values are simply not there because they're automatically defaulting or something like that. And then each time you hit or you don't hit a value, then you would have to refresh your state. And you can be smart about it, right? You can be checking stats of files only, but it's kind of makes it expensive. Git doesn't do that either. It's more like, I think even Git sees it as a snapshot, but it's just me not really knowing what to do. I know that here the git config in libgit2, I think it does have the notion of a snapshot. Where is it? There. To look at a consistent value. So I have the feeling that libgit2 has some sort of implementation that actually validates the freshness of each file and works like that. But I think that's only libgit2. So yeah, you're right. Okay, long story short, it looks like libgit2 does indeed have some sort of automatic refreshing going on. Here we can't see it, unfortunately. I have to look at the code to actually get through to that. Maybe we do that just for fun, real quick.
Yes, it also depends. I mean, this is only an issue when you modify the config after the repository has been loaded, basically, right? And then I guess my question is, if you make these calls anyway from the API, if there isn't a way to know then that it's been changed and that you have to refresh it only then, basically, because I think that might be the only case, really.
Yeah, if you change it yourself, then you can keep it fresh easily. If you expect somebody else to be able to change it, why would everybody suffer from that? Like everybody gets the slow version of the git config just because in some situations it might change. And that's really only good for servers, I think. And even these, I don't know yet, right? Git Oxide isn't there yet. Just checking here, like if there's the notion of an error, sorry, of a refresh, I would expect to see this here. Like if it's not found, then does this automatically refresh somewhere? And it's not really obvious if it does it, at least. Refresh, load, payload. And there's different git config backends. There's snapshot here. And yeah, I don't know. I really don't know. I have to look into that more. But I think it's kind of an edge case at the very best. I wouldn't even bother. But you know, until that's not clear, maybe just drop it here and say, yes, it's not pretty, but it's okay. It's a special case already here that we have to change that on the fly. We would usually do that using our own implementation, and then it's easy to fresh the in-memory or keep the in-memory representation fresh. And we can't do that yet. I think this is what makes this go away. This should be gone. Change it in memory, or maybe write it as well. I don't know, whatever. And then you can do this, and it will work. Cool. For next, let's write it to do at least. To do this in memory without writing to disk. Yeah, and that gets rid of a lot of complexity. Cool, but that's it, I think. And then for completeness, yeah, it's really good. That we could already use in vergen. Let's see how difficult it would be to put this into the object, because we said object short ID would be nice to have, which is really just a shortcut. Is this here somewhere? Here's object, and here's some implementation into own detach. So there's lots of impl blocks here. Usually I document them to say what the topic should be if there is multiple input blocks, especially in the same file and directly next to each other. So let's find the right one. If this is still organized in some way. So short ID, it's more like some access thing, the ID. I think it's a public member anyway, but short ID would be ID prefix. Something like that. So yeah, let's just put it somewhere. feel like a new input block here. Maybe that's what I felt before as well. This is why there are 3 of them. From data into tree, some conversions. Okay, put it where conversions are. To owned, into owned, detach. Okay,
Makes sense.
let's put it here. There's more conversions down here though, to commit ref. Yeah, I don't know. I put it into the smaller one. No, wait, this is all ownership here. Maybe let's put it here, whatever. That's the biggest one. Pub short ID. And that's really, it's really this. A git hash prefix, and then, oh no, we don't have easy anymore. Where is that? It's, yes, it's an ID prefix error. Yes? Yes. Okay. That's interesting. Oh, that's interesting. Just found a bug. So I don't know how this would even work, but people, you know, this is kind of returning a private type here. And this means you can't even match on it because you can't really access this error.
Mm-hmm.
This was supposed to be public.
Okay.
And Rust allows that, and I think it's for good reason. It's just sometimes a bit confusing to see that this actually works, because often this doesn't work. Okay, cool. Return the shortest possible. Oh, okay. Turn this object into a shortened ID. I think that's more like the same. Turn this object's ID into a shortened ID with a length in hex as configured by core abref. Okay, pretty much the same thing.
Good.
Okay, what do we have? We have self-kind, repo, data, ID. Okay, how would you implement that?
Well, we have a reference, right? So it's basically just, I'm guessing, cloning the ID and then getting the prefix for that.
ID, prefix. No prefix on this one. This is an object ID, which is just a plumbing ID. So usually the public data on these objects that they wrap, it's really just plumbing as low level as possible, and then everything higher level is implemented in methods. But we do have access to the repo. So how do we turn this ID into an ID that we can call prefix on?
Can you kind of attach it to the repository like you did before?
Attach, it's there. Self repo. And this one's create ext object ID ext. So these are extension traits. And that's a way to add methods to objects that you own or that you don't own. So in this case, git hash object ID is another crate, and there is no family here of crates, right? So as far as Rust is concerned, it's a crate you don't own and it's a foreign thing. But since I do own the trait here as I define it in this crate, I'm allowed to implement this trait for any type that I want to implement it for. And down here you see that it's implemented for object ID. So attach is really just creating a new ID, and it puts itself into that thing, copies it.
Right.
And, you know, it's really just wrapping this And that wrapping you can do by hand, of course, but you can also do it fluently thanks to these traits. And that's really, really cool and powerful if you think about it, because yeah, extension of objects, of any kind of object, and that's what traits can do. And the first time I've seen this is in Ruby, actually. Then Ruby, this goes all nuts by you being able to change everything. And there's no rules. And this means you can change invariants of other people's codes unknowingly. And this is what Rust's system is designed to prevent.
Right. So you can't just change someone else's, you kind of wrap it in your own version and then you're free to adjust it how you need.
Yes. And the reason for this is the need to use traits. Like you have to bring them into scope. So somebody else can do the same thing. They can have some other trait that is named differently that also has attach. So how do you know which one to call? Is there some ambiguity, or can people just swap your stuff? No, they can't, because you decide what you call. And that's it. That's why Rust works, and this is why Rust is explicit and nice to use. And that's what we're doing. Cool. So that's already it. Let's see if I can quickly drop down a test just to call this thing once and see if it makes any sense. Do I have tests for objects? I'm looking at you, easy object. So here we test decode, head commit, object size and memory, tree. I can probably just go with basic repo. Maybe start here with the question marking. While we're at it, maybe just upgrade this one as well to use question mark instead. Okay, like this. Hey. Head commit, basic repo. Okay, so that's kind of the preamble that always repeats. Short ID.
Excuse me.
I was marveling at the white texture of the wall, though. It's
it's so beautiful.
So this could be probably the baseline here. Then you have a commit, which is what? It's an actual commit. Oh, interesting. Is there one that is just an object? No. It always goes for... Okay. Yeah, so that's interesting. It always wants a commit here. I wonder if I can just have an object.
Oh yes, because we're not implementing it on these special types, basically. It's just the raw objects.
Yeah, yeah. And maybe that tells you, you want that? Do you want to have it only on this one or not? Oh man. So you also can't really go back. Or maybe you can. Can you? Let's see. Let's see if you can. So usually I want to implement these conversions that should work. You should be able to convert from a commit to an object losslessly. Because yes, they're pretty much the same. And it looks like this conversion is not implemented. So probably that should be implemented, because that is definitely doable.
That would make sense, yeah.
And once we have that, short ID can be called, and that is then something that we can probably validate here. Short ID, yeah. I think we want to know these macros. When there's a macro in the way, IntelliJ doesn't work anymore. So object ID, that's the one that it should match. So that could be the test. Cool. And we just add this one thing that I think should work, converting a commit back to an object. And it doesn't like this. Oh yeah. Right, it's a comparison, so it's ordering equal. Okay, down to just one issue. Back to object. Yeah, it doesn't, I don't know why sometimes I can't go back. Why is that? And we are here, object, mod. So usually I have an extra module just for implementations of traits. Mod impulse. Ah, look, here it is. Yeah, it's even named like that. So I usually call it mod impulse. And here is a bunch of impulse. So I can convert an object into a detached object. I can try to convert an object into a commit. And now, well, just the other way around, I guess.
The opposite, yeah.
Now let's start with from commit to object. Then we get a commit and we return an object, which is going to be RID. Yeah, that's always the same. Git hash kind commit. No, I got this wrong. It's git object kind commit. Makes sense. Data. And then this self our data. Our repo. Okay, let's see if that works. Dear Rust, you're awesome, but why is there always something that you don't like? Actually, I predicted this, so I'm not even surprised. Cannot move out of here. Move occurs because our data has type vacu8, which does not implement the copy trait. It's, you know what I usually fall for? I read the fat print in red and miss to read this one, which is actually telling you what the problem is, because commit implements drop. And that's what you want to look at. Everything else is kind of confusing because I know that there's no copy for vacu8, but it tries to copy. Like if it could copy, this would work, because then it wouldn't move out of R, which is a commit with drop, but it would just copy. But now it wants to move out of, but it can't because the object must stay complete, must not be partially moved, because otherwise drop cannot be called on the commit.
Don't we own this object here, like the commits?
Yes, but there's this drop implementation, and drop gets a mutable self, and that means it's complete.
Oh, right.
So basically, this makes...
It's still using it invisibly, yeah. Okay.
Yes, yes. it uses it invisibly later for calling drop. And this is why you can't rip it apart like other dumb structs, so to say.
Right.
And for this, there is even a way to handle this, because we can say our repo. Where did I implement this? You can steal things. Free buff? Yeah, get a new free buff. How's this other thing called? Reuse buffer. Oh yeah. Reuse buffer and free buff, and where's the other one? Interesting. I thought I implemented this somewhere. Ah. Yeah, right. Okay. So look, in drop of objects, it calls reuse buffer and it passes a mutable version of the buffer itself. And then if there's something in that buffer, it takes the data out and pushes it onto its queue of vectors to reuse. So we keep memory allocations around. But only if there's something in there. So the trick is to just take the data, similar to how we do it here with memtake. And this clears the data. I just thought there was some sort of utility that we could use. I thought I called it steal. And I did. And it's even available here. Is it? Steal? Yeah, it's available. Cool. So our data okay. And now I can take the data out. And that works. And the tests run. Cool.
There's no other way of doing this, right? So you have to kind of trick it into, yes, you're still complete, so you can be dropped later.
Yes. You must keep it. It's not even really tricking it. It's more like, yeah, is it? I mean, you should definitely know memtake or replace or swap, because that can be really useful to finally treat memory just as memory and say, okay, don't bother too much about this. Give me that and put something new in. That's this one here. Take. Whenever T implements default, C, it just replaces, just swaps memory.
Right.
And sometimes you have to do that. Yeah. And I don't consider it a hack or something. It's just, yeah, makes sense. I understand. I'm complying.
Yes, it does make sense. It's just, yeah, not what the compiler tells you to do, basically.
Yeah. The compiler says, don't do it, you can't do it. And I say, well, let's see about that. Yeah, but it's quite common, honestly. It just, sometimes you have to do it. And yeah, it's okay. Yeah, cool, that works. I think this is worth a quick commit, because we put object short ID onto the radar. Okay, we even have a test for that. And that's all there is to it. Cool. Then all this is done. Now we just have to make use of it in vergen. So vergen, where do I have vergen? Vergen still uses my local version of the repository, so I should see that new function and should be able to put it right in. Let's push this in the meantime. And see what we can do with vergen here. Okay. Then where's good oxide? Two impl. I think here we currently use this one here. Commit to hex with ID.
That's correct version.
Yeah, it's the one that probably is correct in most repositories, but it's not quite there yet for the Linux kernel maybe. And you want this to work on the Linux kernel for the day when it becomes fully Rust, of course. No, I'm literally kidding. I mean, let's see how long it will take. Rust is already in there, right? So, yeah, here we do have a commit even, but I think peel to commit in place. Look, this function here. That looks like something we didn't have in that test that we just saw, where there was this big queue of things, this big chain. Let's open it right up again.
Oh, yeah.
Yeah. Remember too, how could it be forgotten? This long, ugly chain with to-dos and unwraps. And head commit, huh? So once you have a head, you can now say peel to commit in place. And then you unwrap. Yeah, right, see? To do, done. That's better, I think. Does it still work? Looks like it. Okay, cool. Okay, peel to commit in place. Now we have a commit here and just try to get the short ID from that. You know, I was thinking maybe like we really want to do this. Oh no, wait, not this. We want to do this. And then...
Sure, I mean, that would look very nice.
Actually, we can't do that yet because we can't convert that to a string just yet. Not yet. So that short ID is still the prefix. Yeah. Okay, let's see how far we get with this, but this is what we really want. And most, like, look at this. Most of the time, your short ID is pointing to commits. This is how you work. You work with commits in Git. And I think if you put short ID on some object, like this should be on a commit and not on object.
Yeah, okay, I get that, but it should be on all of them essentially, right? That's, if you think about it.
Yes.
I mean, it should either be on the common ancestor or on all of them. And of course, maybe commit, yes, because it's the most common one, I get that. But I think having it on object is probably also a good idea.
Yeah. Then you have to be non-lazy. And I mean, it's just one line of code. I mean, it's probably okay to be non-lazy there. Okay, fine. Just because we're recording this. And I copy this. So do we have commit tests somewhere? Commit tests, no, but I think easy object is just for all. Ah, look, it is a commit test here. I'm actually in mod commit. I didn't realize that. So this is why they all work with commits.
It was meant to be there.
Yeah, it was meant to be that, and what I'm doing here is a total hack. So yes, it should be this. And Oh yeah, right, this conversion here, not needed anymore. No, short ID wasn't found. Fair enough.
Right.
Okay, you say you think it should be in all of them. You're right, you're right. It's just, I don't want to, you know, it has to be on commit for sure.
I mean, I get it. Then you have to have 5 different places where you have to update this if necessary.
Yeah.
It's
yeah, I'd rather, you know, short ID is already a convenience. Let's, you know, I want people to create an issue and say, I need it there. Why isn't it there? It should be there. And they're kind of right? They are right. And then they probably would get it. So where is it? Object, commit here. There should be some input blocks. Right here. Okay. And now it's only on where it should be, and it's there. Cool. Interesting how code basically tells you what it wants to be. Just have to, I just need a need, pull, like coding based on the pull principle. You know, don't push, just have demand dictate.
Let it come to you.
Yeah, then demand tells you what you need. It kind of makes sense.
Yeah.
Okay, seems like I closed vergen, but yeah, we know we want to do 2 strings, so let's have a look at the 2 string thingy of what's returned there. And this is just a prefix. And for this, I think we also have a bunch of tests. Prefix, yeah, mod prefix. So to get this right, you would just need to implement display. And display then makes toString available. So we can implement this here somewhere. Maybe just drop it in here because we always have a prefix. How long is that? 7?
Anywhere, yeah.
You can just test any of these prefixes and see that it's looking okay. Assert equal prefix toString should be one, 2, 3, 4, 5, 6, 7. Okay. So that should be possible.
Yeah.
Let's see. And we see it should implement FMT display, but it does not. Okay, cool. That should be easy. So the easiest, most stupidest implementation of this, what would that be? Reusing what we already have, because we can do this. We can convert an ID, an object ID, to a hex of a given length. And we know the hex length even, right? We know everything. Just have to implement it. Mod prefix. Yeah, let's put this in here. Okay. Just do some refactoring now that I'm at it, because I think since we do have a module called prefix and prefix is so distinct, I'd rather put that in here and maybe even make it its own. Now we can simplify this a little because it's always prefix error. Import the types we need and should be done. Okay. Cleanup done. And now we have a little bit of space here to dump additional input blocks for. let's say, impl std fmt display, because that's not in the prelude display, so we have to explicitly refer to it.
Use the path.
Use the path. But then, and that's the best of it, honestly. Like whenever I implement a trait, I expect this to be red squiggly lines, and then you can say implement members. And that does most of the work for you. Because otherwise, you have to go there and then copy things.
That's a great feature.
Yeah, it's really changing or making a huge difference. The only annoyance is that it imports types with the short names, and it should learn from how you import the trait and then just qualify it accordingly. If I use fmt display, it should use this. Look at this. Here it uses fmt result because it knows result is already, it would be ambiguous if it wouldn't do that. So it's kind of smart, but also I usually don't want formatter to be imported like this if it's just used once. Call it personal taste, you know, but I like to keep these things self-contained so you can copy them around. This is mainly my drive, and it doesn't look too terrible to have these fully qualified paths. Anyway, self bytes 2 hex with lang, and that gives us a hex display. Hex display itself implements fmt, which means we can call fmt on this one, and then we're done. And this is something that I usually, you know, it took me a while to wrap my head around this. Like, how do you reuse existing implementations and such? And it's kind of easy if you think about it, but somehow I always had trouble because you don't want to write this. You don't want to write something like, you could, of course. You can pass the formatter here, and then you can say, then you can do this.
Yeah.
But it seems complicated because that is the same as this, but more complicated, and there will be more code and more everything. This will not be optimized away. And
this is like the default where my head would have gone to as well. But obviously, if it already implements the thing that you're trying to implement, one level below, it could be as simple as the next line now.
Yeah, you just want to call this, and that's how I started out doing this, I guess, because that already requires you to know that you can pass a formatter as first argument like this to use that as output, because otherwise you would write to standard output. No, you wouldn't write to standard output, actually. You need, this form needs some first argument, which can be a byte buffer, but can also be a formatter. And that's also something to know. But yeah, in this case, we'd rather do that. Let's see. It compiles, and it works. Am I running the right tests? I am. It did actually work. Let's see if it also can not work. And it can also not work. Good. Now we can play around with this little, the one with 7 we already have. Let's have another one that uses less, maybe. And it's hard-coded. Is there some other length that we can test here? Except for the dynamic one, because then we have to, you know, be smart about this and can't just hard code. Yeah. Then you re-implement this. And yeah, that looks like it's also 7. Detects equality. Yeah, we can change this.
You could modify that a bit.
You can change this to 6 and still the same thing. 6. Still the same quality of the test for the test, but now we can at least verify that we don't hard code the 6 here. Or the hex length, sorry.
Anything here?
Yeah. So that I want to verify. And I think that's all you can test here. Sure, we could also have hard-coded that object ID, because right now we have the same object ID in both tests. But I'm okay to squint and say it's good enough.
Assume that's fine.
We wouldn't write that. We don't need to protect ourselves from that. But of course, if you want to be really good, then you would definitely do that. And maybe we can do that easily by just turning this into an A. And now we have 2 different object IDs, right? And that was easy enough. And now the test tests a bit more than it tested before. And I think that's a good thing. It's really, I found that a powerful tool. Not only usually with a pair, but even without, to at least write down the issues that you see with your implementation or the shortcut you take. Like, and this is not as good as it could be, then you write this, in your commit message or talk about it. And then while doing that, it becomes obvious that, do you really want to be that guy?
Definitely not good enough.
Who says that and is okay with it, even though it's not a big deal, but is there something you could do? Could you at least think about that if you could do something? And then usually it's as simple as changing a character 3 times somewhere to not have to write that thing in a commit message. And that's worth it. And sometimes you need motivation. I need motivation anyway, because I'm that lazy, and I tend to be sloppy if I let myself, because that's just the natural state of things. But yeah, and that's it. I think that's good. Now let's get back to vergen and compile this. This could be a nice mark to end this session. Vergen, where are you? Not here. Vergen. Now this could work, huh? Vergen.
This could work.
Oh yeah, this returns an error. Do we have question mark here? Yes, we do. And this is just a result, probably anyhow. Oi. Oh yeah, right. I refactored something. Ah yeah, right.
A bit more, yeah.
Handle and repo. Let's just call this. And it works. It compiles, and in the next session we can see if it works or not. Yeah. Thanks a lot for watching, and see you next time. Bye-bye.
Bye.